Hello there, Mad Scientist Marcus here, and I just wanted to make a video teaching you about time travel, how to slow down time, how to speed up time. So, I just want to let you know this is a controversial, brand new theory. Nobody has come up with this before, so if you're looking for instructions on how to make a time machine, this isn't the video, this is just a theory that would go behind such a device. And like I said, it's controversial. Nobody else believes this. This is just something that I've discovered. Now, ask any physicist what velocity is. Okay, he'll tell you it's change in position over time. Okay, and there's an equation for that. Ask any physicist what acceleration is, and he will tell you it's change in velocity over time. There's an equation for that. Now, ask him what time is, and he can't give you an answer. Why is that? Why is time any different from velocity, from acceleration, from position? Why can't it be defined by an equation? Well, it can. It can be defined by an equation. And every physicist has just overlooked this and hasn't really thought deeply about this. So the equation that I want to look at, that I think is the easiest to understand, there's many equations with time in it, and each of them do define time. And I'm going to look at the easiest one, and that is acceleration. Acceleration is change in velocity over time. So we can just get the time variable by itself. You multiply both sides by time, divide both sides by acceleration, and you have time is equal to change in velocity over acceleration. So now, if a body is undergoing a large change in velocity over a small acceleration, then the time interval is going to be large. And you might say, well, of course, if you're going to change your velocity a large amount and then have a small acceleration, it's just going to take a long time. Well, that's not really what the equation is saying. The equation is saying that the time interval is very large. So what I feel like this means is that if you have a large change in velocity with a small acceleration, then your time intervals are large. The interval of your time perception is large. Now, if you have a small change in velocity with a high acceleration, that means that your time interval is small. So that means your seconds are faster. So what this means is that to be able to make your time interval smaller, what will happen is time will appear, or really will, for you, relative time. If your time interval is smaller, relative time will be slower for you. So you'll see everything else happen in slow motion if you are undergoing small changes in velocity with large acceleration. So if you're moving around really fast like that, then you're going to perceive everything else is in slow motion. Now, if you're undergoing small changes in velocity with large acceleration, then your time interval is going to be smaller, like I said. Now, if you're undergoing large changes in velocity with a small acceleration, like then, so large change in velocity with a small acceleration, then your time intervals are going to be large. So that means your seconds go like boom, boom. So that means that for you, your time intervals are larger. So that means that when you look around, when you look around, everything else is moving faster. So you've slowed down. Well, I guess you've sped up time. So that's why larger creatures like elephants, whales, and things like that, they live much longer than humans even, is because their time goes slower, and that's why, little insects live a lot shorter life, because they're moving around fast. And it's not necessarily even just your physical body moving around, but I think it has to do with the brain, so like the electrons. So, like if your electrons are undergoing, like let's say like a whale for example, like the electrons are going to travel a long way between each connection. So it has a large change in velocity over a small acceleration. And so that would mean that the time intervals for it are longer compared to us. So it would see us moving like really fast. In an insect, the brain is very small, so the electrons will move with small changes in velocity, but with high acceleration because it keeps switching direction. The electrons are kind of going in the brain, and in the elephant brain, they go boom, 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 boom. So for an insect, it has small changes in velocity over a large acceleration, so its time intervals will be small. So it will look up at like a human, and the human will look like it's moving very slowly. And that's why, like um, a fly can like see your hand coming, like, it sees you in slow motion, so it sees your hand coming in really slow, and it's like, oh, I better get out of here. So that's the proof right there, man. I mean, this is a true theory. Now, have you ever fallen? Have you ever like dived off of something or jumped off of a cliff or something like that? And you notice that time seems to slow down. Like you seem to be like falling in slow motion. And I believe that's because you're undergoing a high acceleration. So, the acceleration goes up, so that means that the time in that equation goes down. So the time intervals are smaller. So your time intervals are smaller. So your brain is kind of, not just your brain, but your whole body, it's responding faster. Things are going on faster than the outside world. So it seems like, time is slowing down. So that's his theory. So how can we use that to make a time travel device? Well, it's pretty simple, actually. I mean, if you want to, there's only two things you can do, and that is speed up time or slow down time. So if you want to speed up time, if you want to go into the future, then if you want to go into the future, if you want to slow down time, what you need to do is make your time intervals larger. So that means that you want to reduce your acceleration and make large changes in velocity. So the way that you can do that might be to get away from the Earth's gravitational pull as much as possible. It might be, maybe like, living on one of these bigger planets or something, like Jupiter or Saturn or something. That way your acceleration is smaller and your velocity is larger. Now, if you want to, that's if you want to slow down. That's if you want to slow down time. If you want to speed up time, you want a higher acceleration and a lower velocity, change in velocity, so that your time intervals are smaller. So you want to go into the future. You want to speed up time. Actually, that's the opposite. So really, you can't time travel, okay? The only possibilities you have is to either speed up time or slow down time. If you slow down time, then you're going to be, everything's going to be moving in slow motion, so you can be moving faster compared to everything else that's going on. So that's slowing down time. Now, speeding up time, everything else is moving faster. So you're like fast forwarding your life. So you can either fast forward or slow down. You can't go back. You can't go backwards. That's the key here. You can't go backwards. You can either slow down the progress of time or speed it up. You can fast forward life or you can slow-mo life. There's no rewinding life. So to fast forward life, what you would need to do is make your time intervals smaller. And the way to do that is to increase your acceleration. So go live on like the planet Mercury. Okay? Or some other way that you can make a device to increase your acceleration. Now if you want to that's if you want to fast forward life. Now if you want to slow down life, you want your time intervals to be larger. So your time interval is larger and everything else is going by really fast. So to do that, you want to have a small acceleration. So you want to maybe go live on Jupiter or Saturn or Uranus or something, somewhere that those planets have smaller acceleration around the sun, or come up with a device to give you a smaller acceleration. And then you will see life is going to be happening faster, on things that are on a higher acceleration than you. So I think that's the key. I mean, really, if you want to slow down time, you go live on a planet that's farther away. If you want to speed up time for yourself, then you want to go live on like Mercury or something with a more intense acceleration in the orbit. It's the same with the galaxy and everything like that. So time is basically a function of your change of velocity and acceleration. If somehow you could get yourself out of the game of orbiting around stuff, which, as long as you have mass, is impossible, then what would happen? Well, your acceleration would go to 0, and time would be infinitely long intervals. So that means that in 1 second for you, everything happens everywhere in like one of your seconds. So if you were like, let's say if you were a photon of light, how would you see things going? A photon of light has no acceleration and velocity. Yeah, it does have a high change in velocity. So like as a photon is emitted from an atom, it would have an infinitely large time interval. So its time interval would be infinitely large. So that means that it would see everything else just stopped. It would see everything else stopped. All other life would be frozen if you were a photon. Now, if you had infinite acceleration, somehow you went Super Saiyan or something, and you had infinite acceleration and no change in velocity, or a very low change in velocity, then your time intervals would be very small. So that means that, oh gosh, actually, if your time intervals are very small, that would mean time intervals are very small. That would mean you would see everything else frozen. Okay, if you went Super Saiyan, you would see everything else frozen in time. Actually, and I was wrong about the particle of light. The particle of light has no... Never mind about light. I don't know about light. But if you took yourself out of the universe as an observer, and you weren't accelerating, you weren't moving at all, or if you filled up the entire universe, you would have no net acceleration. Then your time intervals would be extremely large. So that would mean everything would be going super fast. You would see everything happening. You would see everything happening in front of you. And one of your seconds would be like 10,000 years or whatever, 1,000 years. And that's how the Bible describes God. So if you filled up the entire universe, you would have no acceleration, and time for you, one of your time intervals would be very large. So it would take... one of your time intervals would be very large. So you would see all of life happening in a very small amount of your time. All of life would be going on. So it's either everything out there is going super fast, if your time intervals are large, or you're moving super fast and everything out there is slow if your time intervals are small. So you can use that to relate, okay, if I lived on Mercury, all of my time, I would be moving super fast, everything else would be moving super slow. If I lived on Uranus, I would be moving super slow, or my time would be going super slow, everybody else would be moving super fast. And if you take it to the extremes, if you were I don't know, at a place with ultra high acceleration, next to a black hole or something, then you would just be moving super fast and everything else would be frozen in time. Time would be frozen. If you looked out, nothing would be moving except for whatever you're doing. And then if you took yourself out as a spectator out of the universe, or you filled up the entire universe, then your time intervals would be infinitely big and you would see everything happening at a fast forward. Everything would happen in a very small amount of your time. So I hope that makes sense. This is a very controversial theory. Sorry that I had to think a lot because it's very tough to think about, but if you think about it, this is a very important theory. It's very worth thinking about. So thanks for tuning in. Let me know what you think. This could be the Holy Grail. This is, if this information is true, which I think, it proves itself time and time again. All my examples proved it. It's probably the most important discovery of all time. Alright, take care.